Hello, today we will solve the examples on Z transform. So in previous case we have solved the example of this x of n is equal to alpha raised to power n into u of n. Okay, so next we will find the second example, that is a y of n is equal to minus alpha raised to power n into u of minus n minus 1, and this is when alpha raised to power n or n is less than or equal to minus 1, and this is 0 otherwise. Okay, so we have to find the Z transform as well as ROC and the location. Find Z transform, ROC and locations of poles and zeros. Locations of poles and zeros. Okay, so this is, we can say this is a left-handed signal. From the prima facie we can say this is a left-handed signal, and therefore the Laplace transform, that is y of z of this is equal to summation over n equal to minus infinity to infinity alpha raised to power n u of minus n minus 1 into z raised to power minus 1, and negative sign we have taken outside. So this is the value of x of y of n. Okay, so here we can write here minus summation over n equal to, we can change the limit now, minus infinity to minus 1 alpha raised to power n into z raised to power minus n. Okay, so as this value is unity, therefore we can write like this. Now x of z is equal to here we can put here, because here the limit is changed, therefore we will substitute here n is equal to minus m limit has changed here, so we will substitute here m is equal to minus m, and therefore x of z is equal to minus summation m equal to 1 to infinity a raised to power minus m into z raised to power m. Okay, so here it is a minus summation over m equal to 1 to infinity. This we can take a raised to power minus 1 z raised to power 1 raised to power m. You can write like this, and this is the geometric series of the infinite length. Therefore, we can write here like this, minus a raised to power minus 1 z divided by 1 minus a raised to power minus 1 z, and this is converges for only for 1 minus a raised to power minus 1 z, which is greater than 0, minus 1 raised to power z is greater than minus 1. Therefore, minus a raised to power minus 1 z, this magnitude should be less than 1. So what is the ROC here? It is the magnitude of z upon magnitude of A, that should be less than 1, and therefore z is less than magnitude of A. Okay, so x of z is equal to minus a raised to power minus 1 z divided by 1 minus a raised to power minus 1 z. So this we can also write like this, minus a raised to power minus 1 z minus 1 raised to power z 1 minus 1 over raised to power minus z minus 1. So this will get cancelled. This will get cancelled. Now it is 1 over 1 over a raised to power minus 1 z minus 1. Okay. Now here we can also write like this, minus 1 1 over this we can write a z raised to power minus 1 minus 1, and this we can also write 1 over 1 minus a z raised to power minus 1. And this becomes here 1 over 1 minus a z, and 1 over z minus a over z over z minus a. Here the ROC is magnitude of Z is less than A. Therefore, minus alpha raised to power n u of minus n minus 1 is equal to Z over Z minus A. With ROC, magnitude of Z is less than magnitude of A. Draw the Z plane for this. This is alpha. This is of unit circle. Therefore, your Z's magnitude of Z is less than E. Therefore, this is your region of convergence. This magnitude of Z is less than 1, and this is also your ROC. This is the unit circle. This is real part of Z, and this it is imaginary part of Z. So what we can conclude from this? We can conclude from this the conclusion is that from x of n alpha raised to power n into u of n, the Laplace transform is Z over Z minus alpha, and this function, that is a y of n is equal to minus alpha raised to power n u of minus n minus 1 is also, this is y of z. The function given is here because it is mentioned in y of z. Y of z is given. Okay. So what we can conclude here? We can conclude here, therefore, x, here x of n is equal to alpha raised to power n u of n. This pair is z over z minus a, and ROC is here for z is greater than alpha. ROC z is greater than here alpha. This is alpha, and another signal, that is y of n, it is given, which is minus alpha raised to power n u of minus n minus 1, and the z transform is again same, z over z minus alpha, but ROC is here, the magnitude of z is less than magnitude of alpha. So what we can conclude here? We can conclude here having the same transform but different ROCs, having the different ROCs. Okay, so this we can conclude from this. This is a different ROCs. Next is the unit impulse function. Del of n is equal to, this value is equal to 1, or n is equal to 0, and it is 0 for n is not equal to 0. Okay. Therefore, x of z is equal to summation over n equal to minus infinity to infinity uh, x of n into z raised to power minus n. So x of n is here. Summation n equal to minus infinity to infinity. And it is del of n z raised to power minus n. This value is equal to 1 into z raised to power minus 0. This is equal to, so the z transform of the impulse function is equal to 1, and ROC for this is magnitude of z is less than infinity but greater than 0. This is the ROC for the impulse. Next is the unit step function. U of n we write is equal to, this is equal to 1 for n is greater than or equal to 0, and it is 0 for n is less than 0. Okay, so therefore Laplace transform is x of z is equal to summation over n equal to minus infinity to infinity u of n into z raised to power minus n. So u of n is here 1. To this unit function, we have to change the limit from n is equal to 0 to infinity, and u of n is 1 z raised to power minus n. So this is, we can write 1 over 1 minus z raised to power minus 1 is equal to, we can also write this here. ROC is 1 minus z raised to power minus 1 is greater than 0. Therefore, minus z raised to power 1 is greater than minus 1. Here ROC is here, magnitude of z is greater than 1. Therefore, u of n is equal to 1 over 1 minus z raised to power minus 1, and this is the pair, and ROC for this magnitude of z is greater than 1. Thank you very much for watching the video.